24 or 8?
There were 24 hamsters and 9 cats. And then they went.
Just 24 to 8?
It would be, hold on a second, let me pull up my proper tablet here. In other words, we have 9 cats divided by 24 hamsters.
So it's 3?
Well, if we simplify, what is that ratio if we simplify it? What's 9 over 20? 9 over 24. Let's simplify that.
1/3?
What can I divide the top by that I can also divide the bottom by?
1.
No? How about
9.
3?
9.
No, 9 doesn't go into 24. Okay? But 3 goes into 9, and 3 goes into 24 in that amount. Okay?
Okay.
Okay, if the ratio of boys to girl in a class is 5 to 3, and there are 65 boys, how many girls must there be? So, here's the ratio. We have 5 boys per 3 girls. And that ratio has to be the same, and so I put the boys on top over here, and the girls are the unknown.
So you just cross multiply?
So what do I get next step?
65 times 3.
Which is 195.
And then divided by 5.
Right. 39. So there's 39 girls. Okay, now we'll add in some fractions here. On a certain map, 3/4 of an inch represents 1 mile. What distance in miles is represented by 1 3/4 inch? Help me set up the ratio. What's the ratio going to look like here? 3/4 of an inch represents 1 mile.
So you're just going to write that the 3/4 inch equals 1 inch.
Well, let's make it a ratio. It's 3/4 inches per 1 mile. Okay? And the distance measured on the map is 1 3/4 inches. And x is the unknown. In other words, we want to know how many miles that is. So,
can't you still cross multiply?
So what do we have now? We have 3/4 x equals 1 3/4. And now I divide that by that. Tell me how I'm going to divide that by that.
Do you change it and then just switch the...
Okay, let's do it. Help me write it. And when I change this number over here to an improper fraction, what does it become?
7.
7 over 4, okay. And now I'm going to divide that by 3/4, right?
Yeah.
In other words, I have to divide both sides by that right there. Okay, what's this equal to? What's 7/4 divided by 3/4?
The 4 stays the same, right?
What's that?
The 4 stays the same, right?
Well, no. Let's make this a multiplication problem. So it becomes what? 7/4 times what?
4/3.
Right. In other words, flip the bottom and multiply. And that way it turns all division problems into multiplication problems, which are a lot easier. So, okay. After spending 5/12 of his salary, a man has $140 left. What is his salary? On word problems like this, always start them out by defining your variable. In other words, they want to know what his salary is. Okay, so we'll let S equal his salary.
Okay.
Now, what equation can I write and solve? After spending 5/12 of his salary, a man has $140 left. What is his salary?
Do you do like a ratio box?
Well, let's try to write an equation. Okay, so he spends 5/12 of S, his salary, and he has $140 left. Okay, so they're not telling us what he spent, but what he has left. Well, how much of his salary is he going to have left if he spent 5/12 of it?
0.
Now, hold on. He didn't spend it all. He spent less than half of it. He spent 5/12 of it. So 7/12. So 7/12 would represent how much he had left. 7/12 times his salary, that would equal the $140. And then, again, multiply by 12, divide by 7. Before you do this multiplication, simplify. How can I simplify that?
Make it like an improper fraction.
We got 140 in the numerator and we have 7 in the denominator. What can I divide top and bottom by?
7.
Okay. When I divide the bottom by 7, it becomes a 1. When I divide the top by 7, that turns into 20. Now I have 20 times 12, that's $240. In other words, if you do those simplifications first, then you don't even need to get out your calculator because there's not really any big numbers involved. So, all right. In a local election, votes were cast for Mr. Dyer, Miss Frau, and Mr. Borak in the ratio of 4 to 3 to 2. If there were no other candidates and none of the 1,800 voters cast more than one vote, how many votes did Miss Frau receive? Now this is a little different. The ratio is written like this. Instead of a fraction, it's written like this. Okay? And this was for Mr. Dyer, Miss Frau, and Mr. Borak. And there were a total of 1,800 votes cast. How do you think we should do this one? We want to know how many Miss Frauer got.
Would you add them, divide by 1,800, and then divide it by 3? I mean,
yeah, essentially. You're not saying it quite right, but what fraction? In other words, what are these three numbers total?
What?
What are these three numbers over here total?
Oh, sorry. 9.
Okay. So for every 9 votes, she got 3, right? In other words, each of these people, he got 4/9 of the votes. She got 3/9 of the votes. And Borak got 2/9 of the votes. Well, this reduces to 1/3. So how many votes did she get if she got 1/3 of the total votes? What's 3 into 18? In other words, we're going to multiply the total votes times 1/3. Yeah, she got 600 votes. So when you have ratios where there's more than 2 quantities like this, add them up and figure out what piece of the total each person got. Okay, these really are algebra problems. Next one says, if the weight of two ships is 5 to 9, and together they weigh 5,600 tons, how much does the larger ship weigh? So the ratio is 5 to 9, and incidentally, that's the same as this.
Okay.
Whether we write it horizontally with dots or we write it as a fraction. The total weight of the ship is 5,600 tons. So they want to know what that ship weighed.
Oh.
Okay, let's do it just like we did the previous problem. What's the total? Well, what's
40.
the 14? And so this ship weighs 9/14 of the total weight, right?
Yeah.
So now just multiply this weight by 9/14. And again, they make it so you don't really need a calculator. 14 goes into 56 4 times precisely. So I can cross that off, cross that off. Now multiply 9 times 4, 3,600 tons. Now notice that if the big ship weighed 3,600 tons, the small ship must weigh 2,000 tons, right?
Yeah.
Well, is that in a 9 to 5 ratio? Well, that's 36 to 20. Is that the same as 9 to 5? Yeah. 9 divides into that 4 times. 4 goes into that 9 times. 4 goes into that 5 times. So there's that 9 to 5 ratio. Okay. Let's do a little bit of practice on A+ math. You tell me your answer, I'll type it in.
Okay. -4.
Go ahead.
-7.
Good.
I'll check with it. 55.
Good.
$4,900.
Okay, this is division.
Oh, that's division.
That's what that funny symbol means, you know. They use a right parentheses and a horizontal line to be the radical sign. So what's minus 70? There you go.
-30. No, just 30.
That is subtraction.
7.
What's that one doing in there?
3. -27. -12.
Wow, same one. Huh. What's this?
144. No, wait.
Division.
What?
Division again, yeah.
8. -8.
Okay, turn your let's treat subtraction kind of like we treat division. Turn it into an addition problem. In order to turn it into an addition problem, I change that to a plus, But when I change that, I got to change the sign on that also. So the problem really becomes minus 5 plus 3.
So 2, -2.
Negative 2. That's the only ones I've seen give you really any trouble, is when you have a negative number minus another negative number. Let's just go over, let me make some of those up, just to give you a little practice here. Turn it into an addition problem. This is the subtraction sign. That's a negative sign there. That's not a subtraction sign. That's why this problem causes confusion for people. You need to figure out what is the subtraction sign. What we really have here is a negative 7 subtracting a positive 9. So if we turn this into an addition problem, well, we take our subtraction sign, change the sign on it, and then change the sign on the 9 to be a negative 9. And then what's that equal to?
Negative 16.
See, it becomes easy once it becomes an addition problem.
Negative 15.
This is not an addition problem. We can turn it into an addition. The only subtraction sign here is that right there. The other two dashes are negative signs. So if I'm going to turn it into an addition problem, I change the sign on that, but then I have to change the sign on that also.
So it's 1.
And these are the ones that do give you some problem. Let me give you a few more of these.
Okay. Negative 2.
Good.
Three.
Good. All right.
Negative 13.
Good. All right. I think you've got it now. Let's just do a few more here to reinforce it. What's this?
Negative 6. Negative 2. Negative 7. Negative 3.
Good.
Um, 11. Negative 12.
Yeah. See, nobody has problems with a negative number adding to another negative number.
Negative 16. 5. Negative 19. Negative 81. Negative 2.
All right, that's enough. Good practice. Okay, good. You're getting better at those. That's going to help your math skills tremendously. All right, let's see. If a laboratory has 55 rabbits, some white, some brown, which of the following could be the ratio of white rabbits to brown rabbits? I don't like this problem. It's multiple choice. We don't want to do that one. Here, let's do this one. A ratio of 3 1/4 to 5 1/4 is equivalent to what? Convert that to a proper fraction.
8/4.
Okay, the way you convert these to proper fractions is multiply that times that and then add that. In other words, since we want to turn it into fourths, how many fourths is 3? 3 is 12 fourths. So if I multiply that times that and add that, I get 13 fourths.
13. Okay.
Do the same thing on the
I
bottom.
thought you added those two.
Do the same thing on the bottom.
21/4.
And how do I convert 5 3/4?
What?
Convert that one to an improper fraction.
23/4.
Yeah, same thing. Take that, multiply it by that, add that. Okay?
Okay.
Now, simplify that.
Do you just subtract 21 and 3? That's 13?
No. How do we divide by fractions?
Oh, you make it a multiplication problem.
Okay. So it becomes 13 fourths times 4/21. And the 4's cancel. So you're left with just 13/21. And notice that if we go back to the original problem, if you have two fractions and the denominator is the same, you can just drop it. In other words, I can drop that like that. I don't have to go through the process of flipping and multiplying. Just be careful, because if your numerators are the same, you cannot do that. In other words, if I have 4/13 over 4/21, my numerator is the same for each above and below. And notice that if I flip this and multiply, I end up with 21/13, not 13/21. So when I have this situation, I can't just drop the 4. It would be wrong to just do that. I don't have 13/21. So the only time you can drop that numerator is when it's in each denominator.
Okay.
Looking at other problems here. I think you got ratios pretty good. Percents. How are you at percents?
Okay. Not the best.
What's that? Percent what?
67%.
Okay. What is that percent-wise?
0.67%.
Okay, you got it down. What is this in decimal?
3.25.
All right. I don't even know why they have a whole chapter in this book on percents. In fact, let's skip past it. Powers and roots. Okay, this is good stuff. We need to be able to do this. How would I do this operation? Can I
You can just add the 2 and 3.
Okay, so that's the same thing as 37 to the 5th.
Yeah.
All right. What is
1 and then the third?
Last time we were multiplying, so we added the exponents. This time we're dividing. What are we going to do with the exponents?
No, divide them?
Subtract.
No.
Subtract.
Okay, sorry.
Subtraction goes with division. Addition goes with multiplication. Well, the exponent down there is a 1. So if I subtract the exponents, that's my answer. How about this?
Six to the 7th power?
No. The only time you can add those exponents is if the base is the same. In other words, if I have any number to an exponent, and I'm multiplying it by the same number to a different exponent, then I can add the exponents and just bring the base over. If it's a different number, I can't do anything with it. In other words, I could convert these to numbers, but I can't simplify it. In other words, that's 8, and that's 6 or 27, so I can multiply 8 times 27, but I can't represent that as 2 or 3 to anything. Okay?
Okay.
So, that's very important. You have to have the same base in doing all of these. Well, what have I had? So we know that b to the x times b to the y equals b to the x plus y. And we know that b to the x divided by b to the y equals b to the x minus y. What if I had b to the x and I raised the whole thing to the y power? That's the third most important case. What is b to the x? Well, multiply the exponents.
Okay.
Okay? In other words, that's the answer. Notice what's going on up here. Addition is one level less than multiplication. Subtraction is one level less than division. And multiplication is one level less than double exponentiation, or whatever you want to call what's going on the left side here. You can just call it exponentiation. I like to call it double exponentiation. But every time we drop one level mathematically with the exponents compared to what we're doing to the base. Okay? So, what is this number?
You multiply it every 4?
Uh-huh. So it's 2 to the 12. Okay? So those are really the big three, or those three rules. Now, there is a different situation where if I have a to the x times b, a different number, but to the same exponent, I can simplify that. That's equal to ab to the x. So it's not always that you can't handle different numbers, but you either have to have the same base or the same exponent before you can simplify these things. All right, let's end it there. Hold on, let me make a note. Today's date, and I'll know where to pick up on Wednesday. All right, this is good stuff. This is exactly what you're going to need to prepare you for algebra.
Okay.
Okay? All right, Jenna, I'll talk to you on Wednesday.
Okay, bye.